Okay, so it's great to be with all of you. I'm going to be talking about my personal journey in science and faith and some of a few of the things that were significant to that journey and things that I like to share with people that I talk to about science and faith. So it's especially relevant, I think, today with younger people and college-age students that kind of perceive that science and faith are incompatible with each other. And this has actually been the case for a long time, especially in the US. And so I think, for me personally, it's kind of this mission that I'm on to try to help young people in particular understand that science and faith are compatible. So my interest in science started at a very early age. My dad was an engineer, and he had a telescope and would take us kids outside on clear starry nights to look at the heavens. And as a kid, I started wondering about life's big questions during those experiences. I think a lot of us have that experience of awe and wonder when we are face to face with something that kind of challenges how big we are with respect to the rest of the created order. So looking at the heavens, looking at the stars and the planets, and realizing how far away they are, at least in a conceptual level, even as a kid, made me start thinking about those big questions. Things like, where did all this come from? How long has it been here? Why are we here? How will it end? And is there anyone else out there? And growing up in a Christian home and coming to faith at a very early age, I always believed in my heart that God was the source of all this wonder that we were observing. But I went to secular schools all the way from grade school through grad school. And I heard over and over again in my science classes that the facts of nature had nothing to do with God or religion. And if God was, I thought to myself though, if God was who he claimed to be as the creator of the very universe that we were studying, how could the truth about God logically contradict the truth about his creation? That just didn't make sense to me, even as a kid. So I had a particularly memorable experience with that in my junior high biology class. I encountered my first atheist in that class, and he would go so far as to say, you might as well leave your faith at the door, because what we're going to be studying in here will certainly contradict with what you've learned at church and Sunday school. And so even as a kid, I'm 12 years old in junior high and thinking, this just doesn't make sense to me. How can the facts of nature, the things that we're studying that God is the creator of, contradict who God the creator actually is? So it was a rough time, but I'm actually grateful looking back on it because of the fact that I think that God set me on that journey at a fairly young age to try to figure out how science and faith fit together. So in the middle of grad school, I started working at Lockheed on both the Hubble Space Telescope and the International Space Station programs. And as George mentioned a minute ago, I was designated as Lockheed's corporate astronaut. And I went through literally hundreds of hours of simulation and training exercises. I got my pilot's license. I went through neutral buoyancy simulations, hundreds of hours in these gigantic water tanks simulating space operations, flying on the NASA's KC-135 research aircraft that is fondly and affectionately and accurately, I might add, known as the Vomit Comet. More about that later. And since then, I've done work with some federal think tanks, working on Air Force studies, along with various NASA projects, including NASA's Crew Exploration Vehicle, the Mars Exploration Rovers, and some planning for lunar and Mars missions. And relatively recently, while I was teaching astronomy at Azusa Pacific University, I was asked to write an op-ed article for CNN's Belief blog, which the CNN editor provocatively titled, "Does Big Bang Breakthrough Offer Proof of God?" And as both a scientist and a Christian, I'm really careful with that word proof, because inevitably it comes with a lot of baggage for people. And in the article, though, I mentioned that science is a tool that we can use to uncover the wonders of God's creation. And the public reaction was nothing short of astounding. The article went viral with over 500,000 views in less than a week, 70,000 plus shares on Facebook, and it was in the top 5 worldwide most shared news stories on social media. And on top of that, I received a ton of email, most of which was positive, but it was peppered with just a little hate mail, enough to keep things interesting. And one person even got a hold of my personal cell phone number and called to give me a piece of his mind. And it was not pretty, trust me. Yeah, they are. They be crazy. But this experience really made me realize at a first-hand personal level just how polarized people can be on the relationship between science and faith. In fact, this image portrays what many people think of when they think of science and faith. Really ugly debates between Bill Nye, the science guy, and Ken Ham from Answers in Genesis, where both sides end up not looking good. A big part of my motivation is to pursue a more fruitful dialogue between science and faith and to help people wrestle with the issues that I wrestled with growing up in secular schools and even in the professional working world. So we have to ask, is the conflict really real? There does seem to be a conflict between what I would call scientism and creationism. But I would argue that both of those isms at extremes of the spectrum they're conflating ideas that don't necessarily go together. So science can be successfully practiced without a secular worldview and a belief that science can explain everything. In the same way, Christianity can be faithfully practiced without a sudden and recent interpretation of creation, or an almost magical view of creation. And this is just my take on the issue. Contrary to what you may have heard, 40% of scientists polled in a 1997 Nature Journal study believe in a personal God as well as in life after death. And in a broader study of scientists in the US, Professor Elaine Howard Eklund at Rice University found that 61% of American scientists self-identify as Christians. And this is a study of scientists from the social sciences as well as the natural sciences and the life sciences. Next, if we have time, I know I probably got less time than we started with, obviously. But I'd like to go over a few key pieces of evidence to help you understand why these scientists who self-identify as Christian would believe in God. So for starters, modern science arose in Christianized Western Europe. And science writer Michael Covington writes that Jews, Christians, and Muslims, all monotheists, believe in a creator who made an orderly, rational, understandable universe and gave us permission to investigate and utilize it, thereby legitimizing science and technology and paving the way for modern science. So this list here of devout Christians who all were involved in the early kind of paving the way for modern science and the scientific method are all names that we've all heard of: Roger Bacon, Francis Bacon, Galileo, Robert Hooke, Isaac Newton, and more. And so on the flip side of this, where we see modern science arising out of Christianized Western Europe, we have atheists who can't explain why it's possible for us to even understand the universe. And essentially all of the great minds, as I've mentioned before, of the scientific revolution were Christian. And a number of the people that are listed here on this slide claim that God is the author of both scripture and creation. And this is similar to what we talk about when we talk about the two books model, where God has revealed himself both through his creation as well as through Scripture. So the next piece of evidence that unites science and faith, for me, is the Big Bang. And the Big Bang theory has been called the most successful theory of the universe ever, because all of our observational evidence so far is very consistent with it. And the Big Bang model is based on the idea that the universe is expanding, and it's much more God-friendly than the model that was popular before it, which was the steady state model. So the steady state model was exemplified by Carl Sagan's famous statement that the universe is, all that ever was, and all that ever will be, which says that the universe always existed, so there is no need to explain a beginning for it. And also, contrary to popular opinion, the Big Bang was not a chaotic explosion, but rather a very highly ordered event requiring vast amounts of information. Physicist Stephen Hawking wrote, "If the rate of expansion 1 second after the Big Bang had been smaller by just 1 part in 100,000 million, the universe would have recollapsed before it ever reached its present state." And the odds of this happening just by chance are worse than your odds of randomly picking just the right grain of sand out of all the sand on all the beaches of the world, or picking one specific star out of the universe full of stars. Any faster than this critical rate, and matter would have dispersed too rapidly to allow stars and galaxies to form. And an interview with the LA Times, science historian Frederick Burnham had this to say about God and the Big Bang. He said, "The idea that God created the universe is a more respectable hypothesis today than at any time in the last 100 years. And another piece of evidence comes from biology and studies of the origin of life. The question of how life arose from non-living matter is particularly perplexing. This idea of abiogenesis. How do you get life from non-living matter? And just a single living cell contains as much information as 30 volumes of an encyclopedia. We were just talking earlier about Walter Bradley at Baylor University, and he writes that the mathematical odds of assembling a living organism are so astronomical that nobody still believes that random chance accounts for the origin of life. Even if you optimize the conditions, it wouldn't work. If you took all the carbon in the universe and put it on the face of the Earth, allowed it to chemically react at the most rapid rate possible, and left it for 1 billion years, the odds of creating just one functional protein molecule would be 1 chance in 10 with 60 zeros after it. And this is approximately the same as the odds of a thoroughly shuffled deck of cards being dealt out suit by suit in ascending numerical order. And next, I'd like to take a little bit of time to talk about the teleological argument, which has gone by a variety of different names over the years. The anthropic principle, the Goldilocks principle, the fine-tuning argument, which I feel like Hugh Ross is almost the inventor of the fine-tuning argument in modern times. So I don't want to spend a whole lot of time on this, especially with the time limitations that we have today. But it's just astounding how the list of these finely tuned parameters in the universe, in our solar system, in our galaxy, and on our Earth are continually, we're discovering more and more of these parameters that have to be just exactly what they are in order to get life anywhere. So as with the Goldilocks story, everything has to be just right. Can't be too big, can't be too small, it has to be just right. And so there are so many of these parameters, and I know that this audience in particular is very familiar with many of those. But we look at this list, and then we look at the other planets in our solar system, and we see how absent any possibility of life would be. we look at Mars and we discover a cold, dry world. We look at Venus and we discover a very hot planet with crushing atmospheric pressure, with clouds of sulfuric acid and a very thick CO2 atmosphere. And even though we're now discovering thousands of extrasolar planets or planets around stars elsewhere in the galaxy, all of our space exploration so far has shown that our neighbors in space are not remotely capable of sustaining life of any complexity. There are some of the exoplanets that have been discovered around other stars that could possibly harbor life, but we don't know enough about them yet to be able to say with any certainty. And most of those planets that are being discovered are quite large, and it's very important that life-friendly planets have a water cycle, and in order to have a water cycle, you have to have a planet that is just about exactly the size of Earth. For example, one of the parameters of Earth that is finely tuned is its gravity, which is based on its mass. And so Earth's gravity is finely tuned to be able to hold on to large amounts of water vapor at 18 grams per mole, but not large amounts of methane and ammonia, poisonous gases, at 16 and 17 grams per mole. So you look at that, and in order to have a life-giving water cycle, you have to have a planet that is about exactly the size of Earth. So again, like I say, we've been discovering thousands of these exoplanets, but we don't have any evidence so far that they're capable of sustaining life. So if the Earth is just the result of some cosmic accident, surely we could find some attribute that could be improved upon. But when we look at all the special characteristics of the Earth that make it habitable, such as its distance from the sun, water in all three physical phases, the thickness of its crust, its day-night cycle, the axial tilt, which gives us seasons, its magnetic field, which protects us from high-energy electromagnetic radiation, its unique moon, and its atmospheric characteristics, we quickly realize that we live in a pretty unique and improbable place. If we change any of these essential attributes, it would decrease the likelihood of life existing or continuing to exist. And we see evidence of this life-friendly design, not just here in the solar system, but throughout the entire universe. For example, if the velocity of light were faster, too much radiation would reach the Earth over time. If it were slower, we wouldn't be able to see and study as many stars. If the electromagnetic force were either stronger or weaker, chemical bonding would be dramatically altered. We wouldn't have the right elements and compounds available for life. If the strong nuclear force were stronger or good for longer distances, all the protons and neutrons in the universe could be stuck together in one gigantic mass. Or if the strong nuclear force were weaker, we'd have no atoms more complex than hydrogen. Again, very difficult to build a life-friendly universe out of just hydrogen. If the expansion rate of the universe were slower, or the mass density greater, or the gravitational constant greater, the universe would collapse back onto itself. And if the expansion rate were faster or the mass density lower, the gravitational constant smaller, stars and planets could never have formed. And the list of these different parameters and attributes keeps growing, and Hugh is famous for discovering these new parameters that add to the improbability of getting a universe just like the one we have that's life-friendly. So to say that we're extremely lucky in getting the universe that we have and the life that we have is an extreme understatement. There have been estimates of the probabilities that range anywhere from 1 chance in 10 to the dozens to 1 chance. Roger Penrose, for example, he has an estimate of what it would take to put together a universe that's life-friendly as life-friendly as ours. And he estimates that the chance would be 1 chance in 10 to the 10th to the 1/23rd power. So back this off for a second and look at what statisticians say about probabilities. Once probabilities go beyond about 1 chance in 10 to the 50th power, most statisticians would say that it goes from not just being improbable, but virtually impossible because of all the things that have to line up in order to get a situation to beat those odds. So again, to say that we got extremely lucky would be, from a naturalistic perspective, an extreme understatement. And there are various quotes that we could look at from different people reflecting on this idea. And the quote here from theoretical astrophysicist George Greenstein is a fairly typical reaction. As we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency writ large, must be involved. And I'm sure you're all familiar with Fred Hoyle's famous quote too that says, "A super intellect has monkeyed with the physics." And so the main counter argument to all of this evidence of biofriendliness in the universe is the multiverse hypothesis, which speculates that there might be a large or even infinite number of different universes, each with a different set of physical laws and parameters. And perhaps our universe is the only one amongst all of them to randomly get the set of physical laws just right so that life can exist. But of course, so far there's no real way to either verify or falsify the existence of additional parallel universes that we have no access to. So the multiverse theory technically doesn't qualify as a scientific argument, but rather as a very speculative philosophical argument. And even if we concede the possible existence of additional universes, they still all rely on the existence of orderly physical laws. And this quote is from one of my favorite secular scientists, Paul Davies at Arizona State University. And he says, "If the ingenious biofriendliness of our universe were the result of randomness, we might expect the observed universe to be minimally rather than optimally biophilic." And I love that quote because, if our universe were minimally biophilic, it would not speak so loudly or strongly to a God of love and compassion and care. In other words, if our universe were set up so we were more or less a biology experiment to see how bleak the conditions were that we could survive within, that might be what we would expect from a universe that came about by random chance. But less we would less expect that from a God of love and care. And so I think we can read more into the universe that God has provided us for. I think of Romans 1:20. The truth about God can be seen in His creation, and His characteristics can be discerned, and not just that He's powerful and mighty, but also that He cares for us and He's created a place where we can not just survive, but thrive and flourish. I'm running out of time, so I'm not going to go into the physical laws, but the physical laws for me are definitely another piece of strong evidence for the connections between the science and faith that we have. Quantum mechanics is another area that I would talk about if we had a little bit more time. But I think there's some really interesting connections between quantum mechanics, quantum uncertainty, and allowing space for the miraculous without violating the laws of physics. So to summarize the evidence that science and faith are compatible, There's something rather than nothing, which is a question that all thinking people must consider at some point. Secondly, the universe had a beginning, therefore a beginner or a cause, as both Big Bang cosmology and the cosmological argument, as well as Scripture asserts. Next, the universe has orderly physical laws, and we observe a great deal of fine-tuning in the universe, going along with the teleological argument. Quantum mechanics, again, which I skipped over, allows for the improbable without violating physical laws. And modern science was established by devout Christians. And many famous scientists have faith, and Christians can be top-notch scientists embracing both science and faith. I'd like to leave with this thought. Science is a tool that we can use to explore God's creation, and this passage of Scripture is very meaningful to me. Proverbs 25:2 says, "It's the glory of God to conceal a matter, and the glory of kings to search it out." And I think, he's set up this amazing world, this amazing universe for us. And a big part of it is this kind of interplay between humans and God in exploring His creation, learning more about His creation, but also learning more about the God that's behind it and seeing His characteristics. So thanks very much.